All right, we're continuing with Module 2 and dipping into Lesson 2.2D. We're going to find slope given 2 points. All right, so let's kind of review what we've already learned. We're going to talk about, do the lines below have positive, negative, zero, or undefined slope, and explain your reasoning. So when we look at A, we already know that that has negative slope. We introduced our man semi-slope. And again, when Sammy's slope moves left to right, just like you would read a book, he would go down. Therefore, this has negative slope. And maybe we want to make an estimate of what this slope might be. And we know it's negative. It's not too negative. It's definitely not zero. So maybe the slope is approximately like maybe negative 1/4, something like that. Again, we don't know for sure. We're just making an estimate. All right, looking at B. Again, that's going to have positive slope because if I draw Mr. Sammy Slope again, and he travels from left to right, we know that he would go up. So that would have a positive slope. And B definitely looks steeper than A. It's positive, so maybe the slope is, I don't know, maybe 1/2, maybe something like that. So let's look at C. Uh-oh, definitely going to be undefined slope. And when we talk about rise over run, we could say rise up 2 and run 0. So undefined slope. And if you look at the U in undefined, remember that U is made up of 2 vertical lines. Maybe that's how you want to remember it. And for D, of course, that's going to be 0 slope. Okay, because all horizontal lines have 0 slope. And if you look at the Z, look at the top and the bottom of the Z, what's happening? I see some horizontalness happening. All right, let's look at 2. Explain how you know whether a line has positive or negative slope by looking at a graph. So it's all about direction, and that's, of course, what Sammy's slope helps us with. But if the line goes down from left to right, so if it goes down from left to right, which it does here, right? It goes down from left to right, that's going to force a negative slope. So that's going to force a negative slope. Cool. And if a line goes up from left to right, like this one, that's going to force a positive slope. So I'm going to write that down. If the line goes up from left to right, then we have a positive slope. A positive slope. Awesome. Oops, my S looks a little weird. I'll make up for it. I'm going to move this up just a little bit. So I'm going to look at 3. And 3 says, hey, explain how you know whether a line has 0 or undefined slope by looking at a graph. So we've already covered this with C and D, right? So we want to remember that for all vertical lines right here, vertical lines will always have undefined slope. So if I have a vertical line, what type of slope do I have? Undefined slope. Okay. And then if I look at D, right, that's a horizontal line, and all horizontal lines will have 0 slope. So I'm going to write that down here. If you have a horizontal line like the horizon, right, that's going to have 0 slope. So that's just a review really of the previous lesson. I'm going to move up to 4, and we're going to talk about how we can find slope if we're given just 2 points. Directions. Graph the following pair of points on the coordinate plane and connect them to create a line. Okay, that sounds easy squeezy. Let's try it out. We're going to plot the points 4, 3 and the point 0, 1. Now remember, this is xy, so let's go for it. So 4, 3 is going to be 4, 1, 2, 3. Awesome. I'm even going to put a 4, 3 there, no problem. And 0, 1 is going to be 0, 1. Ooh, and that's a special point. That's the y-intercept. Now I'm going to get out my ruler here. I'm really fancy today. And I'm going to combine those 2 points. There I go. All right. So what's the rise between, I'm on A here. What's the rise between 0, 1 and 4, 3? So I'm going to look at my graph, and it looks like I'm definitely going to rise up because this is positive slope, and I'm going to rise up 2 points. I'm going to put a 2 there. Now I know it's positive slope because if I go back to Mr. Sammy Slope and he moves from left to right, he would definitely move up. But anyway, so the rise between 0, 1 to 4, 3 is definitely 2. Now the question is, how can the y values from both ordered pairs be used to find the rise? Well, if we write down the point 4, 3, and underneath it we write the point 0, 1, What's interesting is rise represents a difference in the y values. The rise is represented by a vertical shift. So if we actually subtract the y values, it's not a coincidence that we get 2, which is the same rise that we got here. So how can the y values from both ordered pairs be used? We can subtract the y values. We can subtract the y values. And when we subtract them, we actually get the rise, which is cool. All right. C, what is the run between these 2 points? So we rise up, and then we're going to go 1, 2, 3, 4. So we're going to run over 4 points. Okay, so that's easy enough. That's going to be 4. But the question is D. How are we going to use the x values from both ordered pairs to find the run? So remember what the run is. It's a difference in x values. It's a horizontal shift. So again, if I write down 4, 3, and underneath it I write 0, 1, and I look at those x values, let's see what happens, and I subtract them. Whoa, Nelly. If I take 4 minus 0, it's not a surprise that I did get the value of the run. So if we subtract x values, we can actually find the run. Part E. Now, using the ratio rise over run, find the slope of the line. Sure, confirm that your slope is correct by drawing a right triangle on the line with the same rise-run ratio. We kind of already did it. So we know that rise was 2 and run was 4. So if I go up 2 over 4, it does work. So again, subtracting values or writing this right triangle, I will actually find the same slope, which is perfect. So rise over run in this case is 2 over 4, which of course reduces to 1/2. Awesome. All right, let's move on to number 5. So I'm going to flip the page and you're going to do the same. And we're going to explore again 2 sets of points and graph them and see what happens here. Whoops, I'm going to move it down a little bit. Okay, number 5. So on number 5, we're going to plot these 2 points, 1, 4, and negative 2, 6. Oops, sorry about that. So I've got 1, 4, and 1, 4 is going to be here, 1 for x, 4 for y. And I'm actually going to label it, so that's 1, 4. And then here I have negative 2, 6, so I'm going to go back negative 2 and all the way up to 6. So that's here because this is 5, so that'd be 6, negative 2, 6. And I'm going to connect those 2 points. And I can already tell that my slope will absolutely be negative. It's got to be negative. Why? Because I'm moving down from left to right. Think about Mr. Sammy Slope. And if he moves from left to right, which way is he going to go down? He's going to go down. Or sorry, which way is he going to go? He's going to go down. Okay, what is the rise then between these 2 points? So in this case, we're not going to rise up to get from this point to this point. We're going to rise down. So we're actually going to go down, it looks like 2 units. Okay, so when I go down 2 units, that's a negative 2. So I'm going to write that here. Now, again, how can those y values from both ordered pairs be used to find the rise? Again, we can subtract them. So if I put 1, 4 here, and I put negative 2, 6, which are the 2 points, and I simply subtract those y values, I'm going to get a negative 2, right? Because 4 minus 6 is a negative 2. So I'm going to subtract the y values. Awesome. Okay. Then it says for part C, hey, what is the run between those 2 points? So again, I rise down. That sounds silly every time I say it. And now I'm going to go over 1, 2, 3. So I'm going to go 3 points over. Awesome. So what is the run? It's going to be 3. But again, for part D, it says, hey, how again can we use those ordered pairs to find the run? Because then we don't have to graph it, which would be kind of nice. And how can we do that? We can use it by subtracting our x values. So if we subtract the x values, we can find our run, which is pretty cool. So again, for part E, using the ratio rise over run, find the slope of the line, confirm that your slope is correct by drawing a right triangle. Here's the problem. We already did the right triangle. So we already went down negative 2 and we went over 3, which is the slope of the line. And it should be negative according to Mr. Sammy Slope. So I think we're in good shape. So again, rise over run in this case is negative 2 over 3. Now, what's fun about this is can we develop, for number 6, develop and explain a procedure for calculating slope without having to graph each point? Hey, I love graphing. You love graphing. Everybody loves graphing. But it can be time consuming. Is there a way that we can find the slope without having to graph? There is. So here we go. So can we find the slope given just 2 points? Okay. And we already know that the slope in this case should be, wait a minute, it should be negative 2/3. We just found it with the graph. So we already know what the answer is. But again, is there an easier way to find it without having to actually graph and plot the points? And there is. We can actually stack the 2 points, right, which is what we did before. And according to what we talked about is to find the rise. The rise was found by subtracting y values. So I'm going to say subtract y values, because that's what we talked about in the last 2 problems. To find the run, which is on the bottom, we talked about subtracting the x value. So subtract x values. Cool. All right, so when we subtract the y values, it's going to be 4 minus 6. So I'm going to write that down. When we subtract the x values, it's going to be 1 minus negative 2, 1 minus negative 2. And then we clean it up, do a little definition of subtraction perhaps, and of course we get negative 2, 3. We already knew what the answer was. The question was, what's the procedure? How can we find it without graphing? And here it is. What is the drum roll, please? Dun. What's the slope formula? It is m, which remember represents slope, is equal to y2 minus y1 over x2 minus x1. What? Okay. So I've had lots of students go, whoa, 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 whoa. What's that little 2? What's that little 1? This is a little confusing. Okay. This is actually y subscript 2, y subscript 1, x subscript 2, x subscript 1. And that seems really confusing. But all we're dealing with are 2 points. And all that little 2 and that little 1 mean right here, and that little 2, little 1, it's referring to y2 is the y value of the second point. So say in this case, that's 4. That's fine. And then y1, say, is the y value of the other point. That's what this is, 4 minus 6. And the x2 is referring to the x value of, say, the second point. And the x1 is the x value of the other point. Okay, so don't think that this is y times 2 or y to the second power. Okay, but that's officially our slope formula. I don't know if any of you guys have ever seen the slope formula like this as well. It's using the Greek delta symbol there, but it can be written like that as well. But this is our bread and butter. Okay, and then of course I have a fun song to go with it. Let's look at number 8. So using the line that passes through these 2 points, we're going to answer the following questions. Okay, I love it. Use the slope formula to find the slope. We're not graphing. We're going to find the slope without graphing this. Okay, so that means I'm going to take 5, 3. And I'm going to take negative 4, 1. And what am I going to do? I'm going to subtract the y values, because the y values will go on top. So I'm going to take 3 minus negative 3 minus 1. And what goes on the bottom? I'm going to subtract the x values. Woohoo! So that's going to be 5 minus negative 4. Okay, and then I'm going to clean it up. So 3 minus 1 is obviously 2. Whoops. And 5 minus negative 4 after you use definition of subtraction is a 9. Okay, so I was able to find the slope without having to graph. But of course, what are we doing in part B? We're graphing. Okay, so I'm going to graph 5, 3, 5, 1, 2, 3, which is right here, and I'm going to label it too. And then I've got negative 4, 1, so negative 4 up 1, and I'm going to put that right here. No big deal. And I believe we want to connect them to create a line. So what's great is as I'm connecting these points, I already noticed that I have a positive slope because I can already picture Mr. Sammy Slope here, right? And I picture him traveling up, so it should be a positive slope. Look at 2 9ths. Draw a right triangle on your graph to calculate slope. This is the stuff we've been doing. So if I'm trying to go from this point to this point, I'm definitely going to rise up 2 units. And I'm going to go over, let's count it, 1, 2, 3, 4, 5, 6, 7. I'm going to go over 9 spots. OMG. It's the same thing we got in part A. So draw a right triangle on your graph to calculate slope. Sure did. And we're looking at rise over run, and we found 2 9ths. So for part D, it says, hey, what did you notice about your answers from part A and part C? Hello. The values are the same. The values are the same. The slope, which can be represented with the letter M, is 2 9ths. So now we know we can find slope by graphing, but we can also find slope by using 2 points. in computation. Pretty cool. All right, we're going to turn the page and we're going to focus on number 9. All right, number 9 at the top, it says, Jason, Stephanie, and Ashley calculate the slope of the line below using these points. Okay. Unfortunately, each of them are concerned they might have made a mistake, in their calculations. Hey, though, mistakes are valuable. So who solved for the slope correctly? Who made a mistake? And if a mistake was made, explain the error. Okay, as I look at this beautiful line, and I'm already thinking Sammy slope, I already know Sammy slope would go up, so I know the slope has to be positive. So thank goodness all 3 of them have a positive slope. Okay. As I look at this, though, and I might use my right triangle, if I'm trying to travel from this point to this point, I'm going to go up 1, 2, 3, 4, 5, 6. So rise up. And then I'm going to go over 1, 2, 3, 4, 5, 6, 7, 8. Yes, your math teacher can count. So already I know for rise over run that this is 6/8, which of course reduces to 3/4. So the thing is, hello, Jason, you got 3/4. Yummy. Stephanie, you got 3/4. Delicious. Ashley, there's a boo-boo. So I already know, unfortunately, Ashley is going to get the sad face, but let's kind of see what's happening. So anyway, my 2 points were 4/6 and -4/0. So I'm going to look at Jason's work. I'm also going to move this up just a little bit. There we go. I like that. And I'm going to write down the 2 points here, -4/0 and 4/6. And as I write down those 2 points, I notice that Jason's going to use them to solve for the slope. Okay, so we're stacking them, and then we're going to subtract those y values. So it's 0 minus 6. And we're stacking them, and we're going to subtract those y values, and those will go on the bottom. And as I look at Jason's work, he did that. He did 0 minus 6. He did -4 minus 4. Awesome blossom. And he got 6. Wait, I'll stick with the orange. He got -6 over -8, which is definitely 3/4. So you know what, Jason? I'm going to give you the smiley on that. I like that. That's going to work. Okay. I'm looking at Ashley's work, and the thing is, can we figure out the mistake she made? Do you see it? Well, let me write down the points again. So let me write down for Ashley, let's see. Let's write down -4/0, and let's write down 4/6. And again, we're supposed to subtract and put the y values on the top. So 0 minus 6 on the top, -4 minus 4 on the bottom. Whoa. What did Ashley do? Because I don't see 6 minus 0 or 0 minus 6 on the top. I see something on the bottom with that. That's not bueno. So it definitely looks like she put the x values on the top, which honestly is really easy to do. It's easy to make that mistake, so don't do it. Okay. So unfortunately, Ashley placed x values in the numerator. That silly girl. All right. So unfortunately, that was her mistake. But what's crazy is I look at Stephanie's work and I notice she gets the right answer, but her work is just a little different from Jason's. See, Jason had 0 minus 6. Stephanie has 6 minus 0. Crazy. So again, let's see what's happening here. If I use the point -4/0 and I use the point 4/6, which are the points they gave me, and I subtract and put y values on top, look at the order. Look at the way Stephanie subtracted. She chose to do 6 minus 0. But the cool thing is she was consistent. Since she subtracted 6 first, she subtracted 4 first. So yeah, I guess she subtracted in reverse from Jason, but she was consistent on how she did it. You guys, that still works. So it's okay to do 6 minus 0 if you do 4 minus -4 and you're consistent on how you subtract. So yes, Stephanie also gets a smiley face. Awesome. All right, let's move on to 10. We're going to graph the line that passes through this point and has a slope of -3. Hang on, let me refocus there. Awesome. Oh, that's so much better. So graph the line that passes through the point -2, 1 and has a slope of -3. Okay. So I'm thinking the first thing I need to do is I definitely need to plot the point -2, 1. I got to have a starting point. So -2, 1 is going to be, let's see, -2, 1 is going to be right here. And then the next thing I'm going to need to do is use rise over run, which in this case is -3 over 1, because I don't have a number on the bottom, so I'll put a 1 there. But I'm going to use rise over run to plot a second point. And what do I mean by that? I'm going to show you. So if I'm at negative 2, 1, I'm going to rise up. I'm going to rise down. I'm going to rise down 3 units. 1, 2, 3, and I'm going to move over 1. 1, 2, 3, and over 1. I can even go 1, 2, 3 over 1. Holy smokeroonies. And that's going to be my line. Wozers. I just graphed this line and I did not even use an XY table. Craziness. Number 11, we're going to graph the line that passes through the point 2, negative 5 and has 0 slope. Whoa, 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 whoa. 0 slope means this thing's horizontal. 0 slope means this thing doesn't, it's a flat line. So I'm going to plot 2, negative 5. So 2, negative 5 is going to be right here. 2, negative 5, awesome. And 0 slope means it's simply going to be horizontal at that point. I'm done. Okay, so I'm going to remember here that 0 slope means horizontal line. Means horizontal line, which is awesome. All right, I'm looking at 12, I'm looking at 13, 14, and 15. Here we go. All right, we're going to calculate the slope of the line that passes through the given points using the slope formula. We're not going to graph. We are not going to graph these things, guys. Okay, we're not doing that. So let's look at 12. Now, does Miss Griffin have a song? Oh, yeah, she does. Okay, so given 2 points, if you want to write down the fact that the slope formula is this, that's fine. But honestly, I don't want you to get so hung up on what y2 is and y1 is. Honestly, I almost think this is more confusing to stare at that. So my suggestion is stack them, subtract them. What? Stack them, subtract them. It doesn't matter the order you subtract, but you have to be consistent. In fact, I'm going to write that over here. It doesn't matter. It doesn't matter the order you subtract. But you must be consistent. You've got to be consistent with it. You've got to be consistent. Okay, what do I mean by this? I'm actually going to take out the baby blue pen. Excuse me. That's how serious things are about to get. Okay. My song is simply this. Stack them, subtract them, y over x, you know. Stack them, hey, subtract them, hey. That's how you find the slope. What? Let me explain. I'm going to stack them, subtract them, y over x, you know. I'm going to stack them, subtract them. That's how you find the slope. So 2 plus 1 is 3. 3 plus 2 is 5. We done. Bam! Drop the mic. Pretty cool, huh? Again, I'm not going to focus on what y2 and y1 is because I know as long as I subtract and I'm consistent, I am good to go. So again, what am I going to do? I'm going to stack them. Going to subtract them. Y over x, you know. Going to stack them. Hey, hey, subtract them. Hey, hey. That's how you find the slope. So it's going to be negative 7 minus 0, which is going to be negative 7, negative 1 minus 2, which is negative 2. Hello, 7 halves. There you go. What's up? Now look at 14. Whoa, on 14, I've got lots of points to choose from. You can choose any 2 points you want. So you can choose any 2 points. Pretty cool stuff. Any 2 points you want, you can choose them. Okay. So I don't know. Maybe I choose 0, negative 7. I really like that 0. And maybe I choose 12, 8. Okay. You can choose other points and it's still going to work out. So I'm going to do 0, negative 7. And I'm going to do 12, 8. And you know what I'm going to do? I'm going to stack them. Hey, going to subtract them. Hey, y over x, you know. I'm going to stack them, subtract them. That's how you find the slope. That's how you find the slope. Okay, so this is going to be then what? Negative 15 over negative 12. And when I divide both of that, I can divide by, let's say I could divide by 3 and I can divide by 3. And I'm going to get negative 5 over negative 4, and that's going to be 5/4. All right, now we're moving on to number 15, and we're going to find the slope on this one so it doesn't get confusing. I might do just a line right there. All right, so we've got 2 points, and how are we going to find the slope? We're obviously going to stack them, subtract them. Y over X, you know, da-da-da-da-da-da, stack them. Whoa, subtract them. Yeah, that's how you find the slope, okay? It's y over x, you know. So -1 minus 8. I'm going to use some definition of subtraction. Oops, this is a -3. Hello. Minus -3. And so as you can already see here, hello, we're going to get 0 on the bottom. Hello. So this is going to be a -9 over 0. Wait a minute. Alert, alert. Because 0's on the bottom, we actually have undefined slope. It's going to be a vertical line, undefined slope. So is there a way we can avoid doing this work? Was there kind of a heads up or something that really gave it away? And hopefully you notice that these x values were the same. Ooh. Okay, so when x values are the same, you will always have undefined slope. So when x values are the same, I'm going to try to squeeze it in here, you will have undefined slope. Not a great squeeze in there, but it'll do. All right, we're moving on to the last page. Holy smokeroonies, we are moving on to the last page. Unbelievable. Okay, so now I'm looking at 16, I'm looking at 17, and I got a little saucy because there's some fractions in there. Okay, again, you can focus on the slope formula, which is this guy. But I think that gets confusing on really thinking what y2 and y1 is and all that stuff, because it doesn't really matter as long as you subtract and you are consistent. So simply just stack them and subtract them, and then you can find the slope. So I stack them, subtract them, y over x, you know, stack them, subtract them. That's how you find the slope. Whoa, whoa, whoa. Do we have ourselves a complex fraction here? Good thing we already did that stuff, right? So 1.5, of course, is going to be 3/2. -10 and -10 is going to be -20. Once you do all the beautiful work, because that'd be 3/2 divided by -20, which of course is going to be 3/2 times -1 over 20. Believe it or not, that's going to be -3 over 40. Holy smokes, I just squeezed it in. Okay, now I'm looking at 17, and we can choose any 2 points we want. But wait a minute, wait a minute, wait a minute. Are you noticing what I'm noticing? That everyone's noticing? These y values are exactly the same. So if we were to graph this, this would be a horizontal line. So if it's a horizontal line, boom, 0 slope. So when the y values are the same, you will automatically know that you have 0 slopes. That's awesome. I don't need to use too much work on that. I don't have to use any work on that. All right, 18 and 19. Calculate the slope of the line that passes through the given points using the slope formula. Sure, after finding the slope, find another point that lies on the same line. Ooh, I like this question. Okay, so to find slope, not a big deal because we already know we've got our song down. We know what's happening. We got our stack them, subtract them. So we stack them, subtract them. Y over X, you know. We stack them, subtract them. That's how you find the slope. So -10, that's a -10. It looked like a 70, but when I reduce that, I reduce both by 5, and I'm going to get -2/3. So the thing is, -2/3 is meaning that this is the rise over the run, meaning this is the change in y values and the change in x values. So that next point can be a lot of different things. But if we're stuck at, let's say, 10 and -6, what's happening is to find that next point, my change in y is going to decrease by 2 points, or I'm going to subtract 2. So I'm going to add a -2. And my run, my x values, is actually going to increase by 3. So I'm going to put a +3 here. So an option of another point would be actually 13 and -8. Kind of cool, huh? And if I graphed it, actually would be a straight line, which is neat. Or I'm going to slide this, put that in the middle. Woo! And I'm going to look at 19. Same thing. I'm trying to find slope. Whoa, whoa, whoa. Heads up. Are you seeing what I'm seeing? Are we both seeing it, that the x values are the same? Uh-huh. So this is going to be an undefined slope. This is going to be a vertical line. In fact, if we were to graph it and I went, let's see, I'd go -5. 1, 2, 3, 4, 5. Looks like I'm going -2 and 1. And just say, let's plot those 2 points. So -5, 1 would be here, and -5, -2 would be here. So if I'm trying to find an additional point, we already know that additional point would be -5 and really any x value. Oh, sorry, any y value. Whoops. Try to make that y look a little bit more like a y, right? It's going to be any point that can fall on the line. So there's lots of answers here. Answers will vary. Okay, so now we're looking at 20 through 25. Move this up a little bit. Find the value of x or y so that the line passing through the points has the given slope. Show all of your work. What? So again, we have everything we need. This is slope. Okay, slope is m. And we have 2 points we're trying to solve. So really, if we just use the slope formula, we've got this. In order to use that slope formula, we have this really obnoxious song we can use. It's called stack 'em, subtract 'em, y over x, you know. Stack 'em, subtract 'em. That's how you find the slope. And what is the slope? It's 2/3. Just set it up as a proportion. So now you have y over 9 is equal to 2/3. You can cross multiply, or basically you know that 3 times 3 is 9, so 2 times 3 would be 6, so y should be 6. Boom. All right, let's look at 21. Again, we have 0 slope. Awesome. So we're still going to stack them, subtract them. Y over x, you know, stack them. Hey, subtract them. Hey, that's how you find the slope. And of course, I'm going to set that equal to 0. Cool. So 4 minus y is 4 minus y. 1 minus -8 is 9. I can cross multiply, or basically I know it should be set equal to 0. So let's see, I'm going to get 4 minus y is equal to 0. I'm pretty sure y should be 4. Done with that. All right, going to move it up. We got 4 more to go. Cool. All right, again, I know that slope is -1/2. I've got my 2 points, so I'm going to stack them, and I'm definitely going to subtract them. Y over x, you know, stack them, subtract them. That's how you find the slope. So you'll notice that I'm not even dealing with that y2, y1 business now. This slope is -1/2. That negative can get a little tricky. I'm going to choose to put that negative to the numerator because that's where I'm most comfortable with it. Now 2y minus 3y, of course, is a negative y. 5 minus 1 is 4. I could cross multiply to solve, or again, I already know that, 2 times 2 is going to give me 4, so I'd multiply by 2 here. So that's going to make, negative y, let's see, has to be a -2, so y would be 2. Ooh, that's pretty cool. All right, 23. Again, I've got a slope of 5/4. I'm going to stack them, subtract them. Here we go. I've got -9x and -5. Cool, cool. So I stack them, subtract them. Y over x, you know. I stack them. Hey, subtract them. Hey, that's how I find the slope, and I'm going to set that equal to 5/4. So 5 minus -5 is, of course, a 10. I have 12x here, and I'm going to set that equal to 5/4. I'm definitely going to cross multiply this bad boy for sure. So now I've got 40 is equal to 60x, and when I divide both by 60, number 25, my apologies, but x that, of course, would be equal to 4/6, which is, of course, 2/3. Uh-oh, Mr. 25, don't get too mad at me. I just squeezed that in. All right, I'm moving this up. 24. Again, whoa, what's up with this 4 plus y? Oh, boy. So again, I'm going to get 8 and 5y. Whoops. And I've got -10 and 4 plus y. So I'm going to stack them. And, of course, subtract them, find the slope, and set the slope equal to -3/7. So here I go. So I stack them. Subtract them. Y over x, you know. Uh-oh. I'm seeing something a little challenging here because I have to take 5y and subtract all of 4 plus y. I'm definitely using parentheses. And I've got 8 minus -10. I'm going to set that equal to -3/7. Again, suggestion. When you have a negative fraction, please super glue that negative to the top number. That's where you're most comfortable. This is an issue. This is an issue here. So I've got 5y minus 4 minus y, and 8 minus negative 10 is a negative 18. I'm going to set that equal to negative 3/7. Now I'm going to run out of room. But lucky for you and lucky for me, I've got this great thing called a sticky. Ooh, yeah. So I'm just going to add that on so I can extend through. Pretty slick. Now 5y minus 4 minus y, that's going to be 4y minus 4 over negative 18. And again, I'm going to set that equal to negative 3/7. So I'm definitely going to cross multiply to solve this thing. So that becomes 7 times 4y minus 4. And I'm going to set that equal to 18 times 3, which is going to be 54, I think. 18 times 3, let's see, is going to be 54. And I'm going to distribute that 7 through. So I have 28y minus 28, set that equal to 54. Then I've got 28y. I'm going to add 28 to both sides. That's 2. What's that going to be? 7, 8, 82, I believe. And I divide by 28. And I divide by 28. And I'm wondering if I missed a negative somewhere, but I don't think I did. I think I'm in good shape. And then I'm going to get y is equal to, holy smokeroonies, I'm going to have to reduce this. Let's see, when I add 28, I think I've got that. And let's see, divide by 2. So I'll have 41 and divide by 2, and I'm going to have 14. Oh, that looks bizarre. That looks bizarre. Hopefully I did that right. I think I did. Okay, and now I'm going to look at 25. And 25, oh, you can barely see it, but I have a slope of 5. So I might just put a line right here. So I'm going to do x minus 1 and 15. And I've got 3x plus 5 and 7. Awesome blossom. So I'm going to stack them and I'm going to subtract them. So let's see what I've got here. I've got 15 minus 7. And on the bottom, I've got the same issue with subtracting. So I have to be careful. So that's going to be x minus 1. But then it's going to be minus 3x minus 5. Whoa. And I'm going to set that equal to 5 over 1. This is not an easy question. Not at all. Whoops. And I'm sliding down. I'm going to slide back up because I already know I'm going to need my emergency sticky. Okay. So 5 minus 7, of course, is going to be 8. And on the bottom, I'm going to clean this up. So x minus 3x is going to give me what? A negative 2x. And negative 1 minus 5 is going to give me a negative 6. I'm going to set that equal to 5 over 1. I'm definitely going to cross multiply to solve. So now I've got 8 is equal to 5 times negative 2x minus 6. So that's going to be 8 is equal to negative 10x. And what's that going to be? Negative 30? Absolutely. I'm going to add, whoops, I'm going to use a pencil here. I'm going to add 30 to both sides. So I'm adding 30. And now I've got 38. Whoops, it's moving a little bit. Is equal to negative 10x. And I divide both sides by negative 10. Oh my goodness. And then I reduce and I do all that fancy stuff. I'll get negative 19 over 5. Definitely some challenging questions there for 24 and 25. And that is lesson 2.2D and how you can solve for slope using 2 points.